All right, let's dive in. Today, we're all about the transformer model. Yeah, the one behind, ChatGPT, Bard, and all that AI stuff that seems kind of magical, and we're going to try to make sense of it all in about an hour. So, before transformers took over, the AI world was a bit slower when it came to language.
Yeah.
Imagine reading a book, but like one word at a time.
Oh, wow.
That was essentially how these older models, the RNNs, worked.
It was incredibly limiting. I mean, RNNs process language, one word after another. So they
Yeah.
really struggled with those long, complex sentences and figuring out how words connect across a whole paragraph.
Exactly. It's like trying to get the meaning of a whole sentence by just looking at one word at a time.
Right.
But then this paper drops in 2017, attention is all you need, and boom. It's like suddenly seeing the entire page of a book at once.
Yeah.
Enter the transformer model using this attention thing to look at whole sentences all at once.
Mm-hmm.
I'm already hooked. Tell me more.
Well, the paper itself is a landmark paper, really. It very clearly explains how this new architecture works and its impact. I mean, it's been huge in the AI world, like really big.
So break it down for me. What exactly is this attention thing? It sounds like the model's like zeroing in on the most important bits of a sentence.
Yeah, that's a good way to think about it. So the transformer uses something called scaled dot product attention,
Okay.
which I know sounds really complicated.
Yeah.
But basically, it lets the model calculate which words in a sentence matter most to each other. Like, imagine you're reading a news article.
Okay.
You naturally pay more attention to the key people, the main events.
Right.
The transformer, it kind of does the same thing.
It's like picking out the VIPs in the sentence.
Exactly, yeah.
Gotcha.
And it gets even cooler.
Mm.
Imagine you have a whole team of experts all focused on different aspects of the same problem.
Okay.
That's kind of what multi-head attention does. It lets the transformer see a sentence from different angles at the same time.
Oh, wow.
It's like it's getting a much deeper understanding of the meaning that way.
So it's not just looking at one thing, it's looking at a bunch of things at the same time.
Yeah, exactly.
Interesting. I was looking at the paper, and they talk about self-attention within the encoder. So it's like each word is checking out every other word in the sentence to see how they fit together. That seems, honestly, incredibly complex.
It is. It's very complex, but it's also really powerful. Think about it this way. With RNNs, it was like a relay race, passing information one runner at a time. But self-attention, it's more like everyone's in a conference call. They can all talk and listen at the same time, so the connections happen much faster and more directly.
So self-attention is like a superpower for understanding, all the little subtleties of language.
Yeah, exactly.
But why is this such a game changer? Like, why is this so much better than the old RNN way of doing things?
Well, the paper, it highlights three key advantages. First, it's much more efficient,
Okay.
especially with those super long sentences.
Right.
And second, because it processes information in parallel, all at once,
Yeah.
training these models becomes way faster.
Okay.
Like, imagine cutting the training time from days down to just hours.
Wow, that's a huge difference.
Yeah. And third, it's amazing at understanding these long-range dependencies in sentences. How a word at the beginning can totally change the meaning of something at the end. That's something RNNs really struggled with.
It's like those sentences where you have to read it 3 times to actually figure out what it means.
Yeah, exactly.
So we're talking faster, more efficient, and better at understanding the nuances of language. That's a pretty big upgrade.
Oh, yeah, definitely.
But did this new approach, did it actually work in the real world?
Well, the results were, they were really something. They tested the transformer on machine translation,
Right.
and it just blew everything else out of the water. Like, it even beat those crazy complex ensemble models that had been trained for way longer.
So this wasn't just some theory. It actually made translations better.
Oh, yeah.
I remember back when using Google Translate was it was gamble,
Uh-huh.
You'd hope it wouldn't just spit out a bunch of nonsense.
Yeah, totally.
But it's gotten so much better. And the transformer is?
Yeah.
I guess that's a big part of why.
It is. It's a big reason. Because it's so good at getting those long-range dependencies, understanding the whole context of a sentence.
Yeah.
It can make translations that are much more accurate and sound more natural.
Okay.
Even for like tricky idioms and expressions, those things that are hard to translate.
It's almost like it's like the models learned to be funny a little bit.
Yeah.
Like it's finally getting those subtle things that make language interesting.
I like that. That's a great way to put it. And it's not just translation where the transformer shines, you know?
Yeah.
Think about all those chatbots we use every day, like for customer service
Right.
or virtual assistants, even those AI companions that are, you know, so popular now.
Yeah.
A lot of them are powered by transformers.
It's true. Those chatbots are getting like scary smart these days.
Mm.
They can understand what you're saying, have a conversation, even adapt to, different ways of talking.
Yeah, it's pretty wild.
Sometimes it's a little creaky, honestly.
Yeah, I know what you mean. The thing is, the transformer's ability to process text and generate text,
Mhm.
while keeping track of the whole conversation, that's what makes it so good for this.
Okay.
It's not just looking at single words or sentences, but understanding the whole flow of what's being said.
So it's like having a digital friend who actually remembers what you talked about 5 minutes ago.
Yeah, that's a good way to think about it.
That's pretty cool.
Yeah.
And what's amazing to me is this same technology is being used for, summarizing text.
Oh, yeah, definitely.
Like taking a super long, complicated document and getting the key points, but in just a few paragraphs.
Transformer models are really good at that. They can analyze tons of text, figure out what's actually important, and then condense it down to the core of what the author was trying to say.
That's a lifesaver for anyone who has to deal with a ton of information every day, right?
Yeah.
Like researchers, journalists,
Yeah.
students,
For sure.
heck, even just trying to stay on top of the news these days.
Absolutely. And then there's those question answering systems,
Right.
like Siri, Alexa, all those virtual assistants that can answer your questions like instantly.
It's crazy how good they're getting. It's like having a walking encyclopedia in your pocket.
It is. It's pretty amazing.
But how do they actually do it? Are they like secretly connected to the whole internet or something?
Well, in a way, they are. The Transformers' ability to understand those natural language questions, like the way we normally talk,
Yeah.
and then search through these huge databases to find the right answer. That's what makes those systems work. It's like having this super-powered research assistant
Yeah.
who can scan millions of documents in a flash to find exactly what you're looking for.
Wow, that's impressive. So we've talked a lot about how the Transformer has, kind of revolutionized things when it comes to language tasks.
Yeah.
But I'm curious, can it do more than just words? What about images or audio? Can it handle that kind of stuff?
You're right. We've been focused on language so far,
Mm.
but the really cool thing about the Transformer is how adaptable it is.
Mm.
Because it's so good at processing sequential data, whether it's words, pixels in an image, or sound waves.
Okay.
It can be used for all sorts of things, not just language.
So it's not just a language model. It's more like, I don't know, a universal understanding machine.
Yeah, I mean, that's a great way to think about it. In image processing, for example, they're using transformers for image classification, object detection,
Yeah.
even generating totally new images.
I'm trying to picture how attention would work with an image,
Yeah,
It's like the model's focusing on certain parts, kind of like a photographer composing a shot.
exactly. That's a great analogy. By attending to different parts of an image, it can understand the visual information in a much deeper way, and that leads to some really impressive results.
So it's the same idea with audio then.
Yeah, same principle. They're using transformers for speech recognition, speech synthesis, even composing music.
It's mind-blowing that this one model can do so many different things, from translating languages to writing symphonies.
It really is, and this is just the beginning. The whole field of transformers is constantly evolving, with new variations and improvements popping up all the time. It's like researchers have found this fundamental building block of intelligence,
Right.
and they're just starting to explore all the amazing things you can build with it.
Yeah, that's really exciting. So looking ahead, what's next for Transformers? What are the big challenges, the big opportunities that researchers are working on?
I think one of the biggest is efficiency. As these models get more and more complex, more powerful,
Right.
they need more computing power to run.
Yeah.
That's okay if you've got a massive server farm, but not so great if you want to run them on a phone or some tiny device.
Yeah, you don't want your phone overheating because you asked your AI to tell you a joke.
Exactly.
Yeah.
So researchers are working on ways to make these transformers smaller, faster,
Yeah.
but without losing any of their accuracy. Things like model compression,
Mm.
where you basically squeeze the model down, or quantization,
Okay.
where you use less information to represent the data.
So it's like finding these clever shortcuts so the model can still do its thing, but without needing a supercomputer behind it.
Yeah, that's a good way to think about it.
Yeah.
And then there's this whole area of research looking at multimodal transformers.
Okay.
We've seen how well they work with text, images, audio, all separately.
Right.
But what if we could combine all that together?
So a model that could understand, like, not just what I'm saying, but also my facial expressions, the tone of my voice.
Exactly. Like imagine a model that could watch a movie and understand the whole plot, the characters, how they're feeling, the music, everything all at once.
That's pretty mind-blowing.
Or a system that could help someone who can't see, to navigate using information from cameras and microphones.
It sounds like something out of science fiction. But this is all happening right now.
It is. It's happening. And this technology, it could change so many things about how we live. It's hard to even imagine.
It's exciting, but also a little, I don't know, a little intimidating.
I know what you mean. Like, with great power comes great responsibility.
Right. Exactly.
So we have to think about the ethical implications of this technology from the start.
Mhm.
We need to make sure we're building it to help people, not to create new problems or make old problems worse.
So it's kind of like walking a tightrope, right?
Yeah.
Pushing the limits of what's possible, but also making sure we don't accidentally create something we can't control.
Yeah, exactly. But I'm optimistic. There are a lot of smart people working on this. And I think we're getting better at seeing those potential problems, building in safeguards right into the technology.
That's good to hear. So as we wrap up our deep dive into Transformers, what's the one big takeaway you'd want our listeners to remember?
I'd say this. The Transformer, it's not just some new algorithm or code. It's a whole new way of thinking about artificial intelligence. It's like we're getting a glimpse into a future where machines can really understand the world, interact with it in ways we never thought possible. And that's both incredibly exciting and, yeah, a little bit scary.
I couldn't put it better myself.
Yeah.
So to everyone listening, I hope this deep dive has, sparked your curiosity, maybe even got you thinking about learning more.
Yeah, me too.
This is really just the start of the whole Transformer revolution, and the next few years are going to be wild.
Oh, right.
So buckle up.